Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, welcome back to this problem. We have, we'll start with our coordinate system right here. All right, so now we have two research teams. One is off in this direction. Whoops, that was supposed to start at the origin. All right, angle of 19 degrees north of east at a magnitude of 38 kilometers from the base here at the origin. The second team magnitude of 29 kilometers, an angle of 35 degrees east of north. All right, so far, if you've been going through this chapter, you've noticed that all of the angles that we're measuring here are formed along in relation to the x-axis. So this one is a little funky right here. Oh, and I forgot to mention, we're trying to find, we'll make this green actually, this resultant vector right here. What is the distance between these two research teams? So, as I was saying, this angle is formed with the y-axis, and that's going to kind of change our math a little bit if we're using sines and cosines. The first thing I would do looking at this problem is I would just find this angle right here and then work with that angle. So if you do 90 minus 35 degrees, you're going to get 55 degrees. And then problem solved. We can just work with that angle instead. All right, so let's get working here. So we've got the x component of these vectors. X component. For this vector on the left right here, it has a magnitude of 38 kilometers times the cosine of 19. 38 times the cosine of 19, that is going to be equal to 35.9 kilometers. And then the x component of the vector on the right here is 29 times the cosine of 55, that angle in relation to the x-axis, which that is going to be equal to 16.6 kilometers. We're going to do the same thing for the y components. Find those. All right, so 38 times the sine of 19 degrees, that gives us 12.4 kilometers. And we have 29 times the sine of 55 degrees, which is equal to 23.8 kilometers. All right, so if we're going to find this resultant vector r right here, we're going to need to notice a few things about how this is all set up in relation to these other two vectors. Oops. Here we go. This is what I want to do. So we're going to draw a lovely triangle right here. All right, so if we notice the height of this triangle right here, the vertical component of vector r, is really the difference between these two vectors in black here. So we're going to find the difference of those two vectors. So if we do 23.8 minus 12.4, that is going to give us 11.4 kilometers. So that is the y component of our resultant vector right there. Where for the x component, because these two vectors are facing in opposite directions, we really want this whole distance right here. that whole thing right here, which is made up of the x component of this vector on the left plus the x component of this vector on the right. This one, right, this distance right here, and this distance right here. So we're going to end up adding those. So we've got 35.9 plus 16.6, which that is going to equal 52.6 kilometers. All right, so there's our x and y components. We can find the magnitude of r using Pythagorean theorem. That is going to give us 53.8 kilometers, and find the direction of it. We use arctangent of the side opposite, which is the height. So that's 11.4 kilometers over 52.6 kilometers. So theta is going to be equal to 12.2 degrees north of east. And there you have it. Hope that was helpful. Good luck on the rest of your homework.